a ratio of integers. So in example 14, I've got nothing but rational numbers. These are all rational numbers. So they can all be expressed as a ratio of integers. But the challenge for you is to put them in. Okay. So I want in your notes, I want you guys, now that y'all can see my screen at home, and you guys here obviously in class are watching as well, I want you to draw this number line on your paper, and I want you to put a little dot, and above or below that dot, I want you to represent each of these 7 rational numbers that I've got on my list. So as a little warm-up exercise for you guys. Okay. We want to order rational numbers. That's a skill that we've got to make sure we're good at. Oops. I got her done. Excellent. All right. Let's see here. Reed Johnston, which one is the farthest to the left? Reed? Earth to Reed. All right, let's try Paul. Paul, which one's farthest to the left?
-3.
All right, so I'm going to put a little dot right there at -3. I'll see which one's the farthest to the right. Four is the one that's farthest to the right, so we'll put it. Now you're looking at the screen. I'm wondering why you weren't looking at your paper there. All right, let's see here. I'll do 3/4. That one's easy, right? 3/4 would be about there. Okay, 3/4. Let's see here. -1/4, right? That would be to the left of 0 just a wee bit. That's simple enough. There's -1/4. Okay. 6/5. 6/5, Quentin. Where would I put it? Just to the right of 1. Very good. Okay. 6/5. All right. I got somebody's chatting on here. I wonder if that's Reed saying my microphone's busted. Yeah, I bet you should go open it up. And if it's a Christian Brothers kid, tell him to buzz off. I dare you. Yeah, Reed says I don't think my microphone is working. Reed, no duh. All right, so Quentin's got the 6/5 there for us. Lewis, what about -5/2?
That's gonna be like in the middle of -3, -2.
In the middle of -3 and -2, so that's -5/2. What might be a better way to look at -5/2?
-2.5.
Yeah, -2.5 or -2.5. That's how we would place it. And then 7/3 is just past 6/3. 6/3 is 2, so let's put it about a third of the way. Right there, 7/3. All right, savvy? Everybody good with that? Okay. Now, ordering rational numbers, when you've got a number line and when they're relatively easy to discern, like we had some common, or not common, common's a bad word there. We had some denominators with which we are already comfortable, okay? We had denominators like 4 and 5 and 2 and 3, so not really confusing fractions at all, okay? So when we talk about kind of ratcheting up the difficulty here, we can look at a problem like example 15 where we say, oh, okay, now Coach Morgan has given me 2 numbers. Let's write those 2 numbers down, 5/8 and 0.75. And again, I'm kind of giving you a little soft toss right here, okay, Joe. A little soft toss. All right, nice and easy for you to swing it. Because these two numbers are, again, going to be numbers with which we are already pretty comfortable. But the technique that we use here, I'm going to give you a harder problem following this up, and it's going to be the same technique. Okay? So it says, find the number halfway between 5/8 and 0.75. First of all, we need to talk about density. Okay, any of you science nerds in the house, y'all love science? Anybody? I don't have any science people. Alex, you look like a science man. You like science? Not really? Okay. James, what about you? Fan of science or not so much? Eh? Man, I'll tell you what, last night, Virginia, my youngest child, Jenny, she came up to me, she had a drawing, and she had a picture of a girl wearing a dress, wearing some glasses or goggles or whatever, and then a couple of like those, I don't know what you call them, but they're typical like beaker looking things. Like that with like a little something in there, I don't know what you call it. It's not a test tube, but maybe it's a flask or something like that. Anyway, the little lady she was drawing had a couple of those, and I said, "Ooh, Jenny, what's this?" And she said, "That's me. I'm going to be a chemist one day." And I was like, "Okay, weirdo. She's 5. Like, how does a 5-year-old know she wants to be a chemist?" But heck, maybe she wants to be. I don't know. But when we talk about density in science, what is density, Mr. Griffith? And put it in your own words. You don't have to give me any kind of fancy science talk. Something per square centimeters. All right, that's confusing. I don't really know what that's all about. What do you think, Oxley? Oh, now we're talking. Okay, so you said mass divided by volume. Let me write that up here. D equals M over V. Is that true? I don't know. I can't remember the formula. Y'all concur with Jake's assessment? Okay. Mass divided by volume. So it's a ratio of mass per volume. Okay, so if something's really massive and it has a really small volume, then it would be very dense, wouldn't it? If something is not very massive, something doesn't have a large amount of mass, and yet it does have a large amount of volume, something would be not very dense. Okay. The notion of density, like thickness isn't a good word because thickness kind of comes, you think of length and breadth and width and things like that. But if it has like sustenance, something that is dense, has got stuff in it. Okay. And the notion of density in algebra is just like that. Okay. The notion of density in algebra is such that if I were to give you a number, okay, let's just say the number 1, and I were to give you the number 2. All right. Between 1 and 2, there's another number. What do we call it? Try again. 1.5 or 3/2. And between 3/2 and 2, there's another number, right? And between that and 2, there's another number. And between that and 2, there's another number. And between that and 2, there's another number. Can you smell what I'm stepping in here? Could we continue that process indefinitely? Yes.
Yes.
Okay, absolutely. It reminds me of a corny joke. There's a mathematician and an engineer, okay? And a sociology professor is going to conduct an experiment. So he takes the mathematician who he's just a normal guy, and he puts him down at one end. He takes the engineer, again, just kind of a normal guy, puts him at the other end of a hallway, long hallway. The engineer, mathematician in the middle, right? He puts a beautiful young lady. And he says, all right, we're going to conduct this experiment. You guys, I want you to take the distance between you and this young lady, and I want you to cut that distance in half. And then cut your distance in half again. And then cut your distance in half again. And the mathematician said, woe is me, I'll never get there. And the engineer said, I'll never get there, but I'll get close enough for practical purposes, like hand holding and saying hello and things like that. So the idea is that mathematically, we could continue to inch our way. Nobody laughed at that joke. Nobody ever does laugh at that joke, by the way. But we could inch our way closer and closer and closer to 2 without ever getting there, infinitely filling up my little number line with numbers. And BT Dubs, Was 3/2 the only number that is between 1 and 2? No. Okay, there's a boatload of other numbers. There's actually how many? Infinitely many numbers between 1 and 2. And this is the notion of density, okay? Remember how I said it's like you got stuff in you? You're thick, okay? Density. So the density property of the rational numbers says that between any two given rational numbers, there exists another rational number. That's the math definition that you should probably write down. The density property of the rational number says that between any two rational numbers, there exists another rational number. So you're guaranteed, I don't care what rational number I could throw at you. If I give you a couple of rational numbers, there's always going to be another one between the two of them. Okay? So this notion of density allows us with great certainty to approach example 15 here and say, aha, Coach Morgan has given me 5/8 and he's given me 3/4. That's the 0.75, right? And he has asked me to find a number halfway between there. So I know I can do it. All right. Now, 5/8 and 3/4. It is helpful to know which one is bigger to start with. How might I do that, Alex? How could you tell me which one of these two is bigger? Say it one more time. Okay, so the notion of simplifying them. Actually, let's do the opposite of that. Let's unsimplify them because they're both already simplified. Okay, Quentin, what is your idea?
Make the bottom numbers even. So
when you say even, you mean the same?
you get it from there.
Good. Make the bottom numbers the same. So how do you want to change that second fraction?
Multiply 3/4 by 2.
How about the clever form of 1, also known as 2/2, and we get 6/8 and 5/8. All right, so very good. Now, if you didn't catch that, what Quentin says, we want to make the denominators the same. That's the trick here. And as I said, these two fractions are fractions with which we should be comfortable. If you've ever done any work, like with maybe you guys work with your dad out in the shop or whatever, and you're dealing with ratchets and sockets and stuff. Your dad's been working on a jet ski recently, I think, right? And like, so if I were like my dad growing up, my dad would always have me out in the backyard helping him. Like, let's say we're working on a lawnmower or we're working on a tractor, or we're doing something like that. And he says, hey boy, hand me a socket to fit this, or hand me a wrench to fit this. And I give him 5/8. I give him a 5/8 wrench, and it's too small. And then he says, all right, give me something bigger. I give him a 3/4 wrench, and it's too big. He says, find me something between these two, you dingleberry. I said, oh, okay, Dad, sorry. And I get over there. What's between them? What number is between them? Well, if we do like what Quentin suggested, which is to make the denominator say 5/8 and 6/8, what 5.58? I don't think so. Oxley, what do you do? How now, brown cow? We multiply both top and bottom by 2. And what number, poof, magically exists between the two? What number? 11/16. And that's what we're shooting for. And that would be the magic wrench there that my dad would need. I don't think he's got any 30-second, I don't know how to say that properly, but wrenches with a denominator of 32. I don't think he's got any of those. All right, so 11/16. Questions on how that worked? Have y'all done that before? Some of you have, some of you have not. All right, I'm going to give you a harder one now. You can't tell I'm smiling behind my mask. All right, I'm going to give you a harder one. Are you ready? Same two fractions. Same problem to begin with. Instead of halfway between, I want the number, find the number 1/5 of the way between these two numbers. Okay. Now, I'm obviously, this is a much harder question, but I'm not going to give you instructions. I'm going to ask you guys to kind of problem solve it. See if you can figure out what to do. Okay. Y'all's little minds are just firing all those dendrites and neural connections and whatnot. Let's see if you guys come up with anything. Okay, and we'll take a couple minutes and look at this. But I want to find the number that's 1/5 of the way between these two numbers. We found the one that was halfway between them. Let's see if we can find one that is 1/5 of the way between them. And while you guys are doing that, I'm gonna go get a water bottle filled up. Good morning. Y'all made any progress? Oh, very good. Making some progress. That's what I like to see. Let's take about 30 more seconds. About 30 more seconds. John Boy, I'm going to put you on the hot spot, Mr. Tacos. We'll get us started here in just a moment. All right, JMZ, what do I do first? What's my job? And by the way, obviously, we already know 5/8 and 3/4 are the fraction ways of expressing it. What do you want to do first?
Make the 3/4 6/8.
Speak up just a little bit for me. Go ahead.
Make the 3/4 6/8.
Did you guys hear what he said? I couldn't hear what you said. All right, sorry, John. I can't. Your mic's a little bit too quiet today. Let's get Kozlowski. Can you give me an idea of what to do? Colin. Earth to Colin. Good night, America, people. All right. I guess I'll just have to call on one of you goobers here. I'm gonna call on Ben Rouse. Is it Roos or Rouse? My mind is blank. Huh? Rouse, like mouse. Okay, good. Ben, what'd you do? Change 3/4 to 6/8. That's probably what JMZ Tacos said. 6/8. And what next? Let me ask you a question. All right, so I'm gonna use Ben as a visual demonstration. You guys that are at home, y'all will just have to listen to this. All right, I'm standing. How far away are Ben and I standing apart? Luke, what do you approximate that for me? How many feet do you think? Each one of these little blocks is 1 foot. So how many feet do you think that is? Maybe 18? 18? All right, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We were close. It's 20 feet. All right. He was 20 feet away from me. He is 20 feet away from me. Okay. Now, how far away would 1/5 of that distance be? What do you think, Ben? 4 blocks. How in the world did you do that? All right. So what is the word? Ooh, this is a mathy question. Okay. Let's see if Mr. Bolio can get this. What does the word of translate to? Tiago? when we're translating like word problems, what does of mean in math? I don't think you and I have written this down, so this might not be in your early morning math folder yet. You want to phone a friend?
Sure.
All right, we're going to call on Mr. Jacobs. What do you think, James? It's not division. It's like the inverse of division. What do you think, Luke? Multiplication. Can we all write that down, please? The word of, all right, I'm going to highlight it. Check this out. Of means multiply. Okay? Of means this translates to multiply. And whenever you guys see the word of in a word problem, buddy, it means multiply. So when we were back here, Drew counted and he said, Coach Morgan wants 1/5 of that 20 feet distance. That means 1/5 times 20. And he got his 4 that way. Okay, so now check this out. We've got the number 5/8. We've got the number 6/8. How far apart are those two guys? Now that we've got the same denominator, how far apart is 5/8 and 6/8? 1/8. So the distance, again, if you can visualize, this is a concept that you guys have to get in your brains, is that if you can visualize, if you can see a problem drawn out, here is a physical distance between these two numbers on the number line. Okay, and that distance is 1/8 in total. Then what is 1/5 of that distance, Jake? Again, why are we dividing? What does the word of mean? Multiply. Now, mathematically, we're going to be fine doing the same thing. But check out what I want to do. I want to cut that distance into 5 equal parts. So dividing it by 5, same thing as multiplying by the reciprocal. So we're going to say that we're going to multiply 1/8 times 1/5. That is 1/5 of the distance between those two numbers. And we get what? 1/40. And 1/40 is going to be the distance that we're wanting to go. Okay? Oh, I wrote 1/4, pardon me. 1/40 is the distance that we're wanting to go. Okay? Because you add up 1/40 and 2/40 and 3/40 and 4/40 and 5/40. And by the time you've added that up 5 times, you've gone the whole distance between those two numbers. So what's 5/8 plus 1/40? 1/40, excuse me. What's 5/8 plus 1/40? We talked about this last week. Tiago, I'm going to pause my discussion and get your question. Go for it, bro. Yeah, I thought you had a hand up.
For the 5/8 and 6/8, I got a decimal instead of.
Ooh, you know what? Real good time to talk about this too. If you didn't hear what he said at home, guys, he said that he, with 5/8, bless you, he got 0.625, and with 0.75 obviously being the other decimal. I would recommend doing your computations in terms of fractions in algebra. There are some times where decimals will work okay, but it just my personal experience, I find that life goes easier when we deal with them in terms of fractions. Just a heads up. Not that you can't do it with decimals, and you guys might feel like you're more proficient with decimals, but try to do it in terms of fractions, and I think that'll suit you better. Make sense, Tiago? Good. All right, so has anybody added this yet? What do? I got to get a common what? Common denominator, okay. Do what? Oh, always. Okay, so what do I have to multiply that by? Is it 26/40ths?
Yes.
And then that simplifies down to 13/20ths. Ooh, doggy. I think we got our answer. 13/20ths. Right there. Winner, winner, chicken dinner. That's the number. That's 1/5 of the way between 5/8 and 0.75. Okay. Now, I'm well aware of the fact that this seems trivial. Okay. Like, who really cares what number is 1/5 of the way between 5/8 and some other arbitrary number that I just threw at you, right? I know this seems trivial, but there's 2 things I'd say. Number one, even with trivialities such as this, you are training your brain. You're having your brain. Like dadgum, yesterday we were waiting for the girls to get out of ballet. Okay, my two little ladies were doing some ballet over in Arlington. And so Teddy and I had him, we were in the back behind the building doing some exercise. And I had Teddy like doing some jump squats and then some jumping jacks. And then he was running his sprints, right? And then, he was doing some push-ups against the side of the car. And when we think about exercise, exercise is often trivial, isn't it? I mean, how many daggum times in your life have you had to, lay down and bench press something up? Like, seriously, think of the number of times you've been on your back and you've had to lift something up like this, right? That doesn't happen very often, does it? But what does bench press do for us? What do push-ups do for us? They make us yoke. They make us part of the swole patrol and make us stronger, okay? So what we're doing here is your brain is doing some push-ups with an exercise like this. I'm training your brain right now to get jacked, okay? And then the second thing is I'll say this. Sometimes I do use this. Now, I like to go out in the backyard in my shop and do some woodworking. And so sometimes it's helpful for me to be able to say, okay, well, how far away from my starting point would be, a certain distance. It's usually not something kooky like a fifth of the way, but, between this and this. So there are, once in a blue moon, there are times where you might do an approach to a problem like this, okay? Now, I digress. Go for it, Lewis.
Why wasn't 1/40th the answer? Why'd you have to add 5/8 to it?
All right, so 1/40th. Okay, that's a great question, Lewis. Think about it like this on a number line, okay? And I'm going to draw a new number line, and we're going to put everything, lay it out all good and well. There's 0. There's 1. And so like 0.75, there's 3/4 right there. And what was our other number? 5/8. So there's a 1/2. And then there's 5/8. All right, so these were our two numbers that we started with, right? Now, where is 1/40th on that number line? Like in actuality. Yeah, that's right. Griffith says next to 0. It's like way on over here, right there. That's 1/40th. Okay, so Lewis, the question wasn't, hey, where does 1/40th locate as it pertains to our other two numbers? Okay, the question is, we determined that this distance right here was 1/8, and we wanted to cut that distance up. I think Oxley had said we wanted to divide it up into 5 parts. And so that part right there, as I zoom in, look at this. That part right there in red, this distance was 1/40th. Okay, just like it was over here. We just wanted to say, hey, let's go 1/40th to the right of 5/8. Okay, and that's why we said let's add 5/8 plus 1/40th. Does that make sense?
Yes.
Okay. And again, fellas, what am I doing when I'm explaining and I'm trying to answer questions? How am I explaining things? With a what? Say it louder. With a visual. And if the way that I explain things is using visuals, the way that you figure things out should be with visuals. Okay? I think all of you, if you were doing this problem, would have done a lot better if you had, drawn it out as opposed to just trying to figure it out in your head. Okay. Same thing with word problems. Same thing with anything we do in this class. Okay. If you can figure out a way to visualize it, you're going to be straight. All right. Last thing I want to do is compare two fractions, and I know you guys can do this in a matter of a minute or so. We got 8/15ths. We got 11/20ths. Is that less than, greater than, or equal to? Okay. What do we want to get? We want to get the same denominator. And that means I got to find the LCD. It's smart to find the LCD, isn't it? Okay. So between 15 and 20, can anybody use inspection and tell me what that denominator should be?
60.
60. Yeah, very good. It was easy, wasn't it, using inspection? Okay. But remember, we've talked about it before where you've got that fallback method where we give the prime factorization of each denominator, circle each new factor raised to the highest power, multiply everything we circled, and that's the LCD. In this case, we don't have to worry about that. What do I do? Hold on there, Skippy John Jones. What do we do, Joe Edwards, to 8/15ths to get it to have 60 as its denominator? All right, multiply the top by 4, so we get 32, and the bottom by 4, and we get 60. And then what do I do, Alex, to get the other fraction set up good? All right, so we got 33 over 60. So we put a big fat less than sign. All right, that one's an easy one to end on. Fellas, I tell you what, I have now procured for you a CBHS email account. I'm going to send some info to you guys later on today, to your parents, and get you guys set up so that what we'll be able to do is from now on, you'll log into Teams when you're at home via the CBHS address, and you'll be able to access all of our stuff. So if I have like little practice ACT problems, if I want to give you guys a quiz one day, y'all can all do that with your new CBHS email account. You're welcome. Have a great weekend. Live Jesus in our hearts. All right, fellas, y'all take care.
I have a question.
Lay it on me, Paul.
Do we have any homework?
No, I think I'll let you off over the weekend without any homework.
Okay, thanks.
You're welcome, buddy. See ya.
Bye.